All right, we're going to look at angles and their measure. It's chapter 13.1. This is kind of an extension of the last chapter, which was chapter 6 that we covered. And we also talked about an acute angle. An acute angle is an angle between 0 and 90 degrees.
An obtuse angle is any angle that is bigger than 90 but smaller than 180 degrees. If you remember a right triangle, a right angle, the two lines are perpendicular to each other. A straight angle is just a straight line. It's 180 degrees. Okay? If you have pairs of angles, then we can talk about angles. Adjacent angles are two angles that have a common vertex. Here, that common vertex is A. A common side between them. The common side here is the side AC. So here, the angle D or CAD and BAC, those are adjacent angles. They share a side and the vertex is the same. We also have vertical angles. It says that if two lines cross to form equal angles on opposite sides of the point of intersection, which is the common vertex, these angles are called vertex angles. So here, the vertex is O. They cross on opposite sides of the O, and these are vertical angles, and vertical angles are equal. Vertical angles are equal. We also talked about in chapter 6 that if the sum of two angles, if that's 180 degrees, then they're supplementary angles. If the sum of two angles is 90 degrees, then they're complementary angles. Okay? So complementary, the sum is 90 degrees. Supplementary, the sum is 180 degrees. Now, let's look at the next picture here. Here we have parallel lines A, B, and C, D. And then we have a non-parallel line that's crossing these two parallel lines. That's the line EF. That is called a transversal. Okay? So AB is parallel to CD. And the line EF is a transversal. So whenever you have a transversal crossing two parallel lines, then we have some equivalent angles here. Corresponding angles are equal. And corresponding angles, here the angle 1 and 5 are corresponding. Okay? The angle 2 and 6 are corresponding. 3 and 7 are corresponding. 4 and 8. Those are corresponding angles. Notice that they sit in the same place. Here 1 and 5, 3 and 7, 2 and 6, 4 and 8. Those are called corresponding angles. Now we also have alternate interior angles. And by the way, corresponding angles are equal. Alternate exterior, well, let's look at alternate interior first. Angles are equal. The angle 3 and 6 are alternate interior. Notice that they are inside the two parallel lines. Those are equal. As well as angle 4 and angle 5. They are alternate interior angles. They are equal. Then we have alternate exterior angles, and they're equal. So 1 that's on the outside and 8 outside of those parallel lines, they're equal. And angle 2 and angle 7, those are alternate exterior angles, and they are equal. Now, let's look and let's at some problems. In number 2, they want us to find the complement of 83. Remember that complementary angles have a sum of 90 degrees. So the complement of 83 is 90 minus 83, which is 7 degrees. Okay? The supplement, remember, for supplementary angles, you have a sum of 180 degrees. So they want us to find the supplement of 27. So 180 minus 27 degrees is 153 degrees. Okay? Complementary and supplementary angles. All right, now we're going to look at this figure 13.10 here. And using this figure, we're going to identify the angles. Okay? They want an obtuse angle. If you remember, an obtuse angle is an angle that is greater than 90 degrees but less than 180. So we can look at this and we can see that CEA is 90 degrees. We need something bigger than that. So if we look at DEA, then we have an obtuse angle, DEA. Now, they also want us to find a set or a pair of complementary angles. Remember that complementary angles, their sum is 90 degrees. Well, we know this angle here is 90 degrees. So we can break this up and we can look at angle CEB and angle BEA. Those are one pair of angles, two angles, whose sum is 90 degrees. And then number 12, they want us to find the supplement of CBD. Remember that supplementary angles, their sum is 180 degrees, which is a straight line. So I need to look to see what makes that straight line. So we have this line in common and then that angle. So we have the angle DBA. That is the supplement of the angle CBD. All right. Now we have a picture here in figure 13.12, and we have some things going on. They tell us that the angle CBD is 65 degrees. They tell us that the line AC is perpendicular to BE, so they make a 90-degree angle. And they tell us that the line FB is perpendicular to DB. So there's a 90-degree angle there, as well as a 90-degree angle there. Okay? And from this, they want us to find the angle EBF. EBF. Well, if we look at EBD, we know that this forms a 90-degree angle, so this angle here is going to be 25 degrees. Okay? EBD is 25 degrees. Now, we know that BF or FB and DB are perpendicular, so they form a 90-degree angle. So this angle 25, this angle EBD is 25, so this angle here has to be 65 degrees. So the angle EBF is 65 degrees. Okay? Just by knowing that we have what? Parallel lines. Not parallel, excuse me. Just by knowing that this is perpendicular. Okay? Which means it forms a 90-degree angle. We need to find the angle FBA. Well, again, we know that EB is perpendicular to AC. So this forms a 90-degree angle. So from here to there is 25 degrees as well. Just by knowing one angle and knowing that we have perpendicular lines, we can figure out a lot of information there. Let's look at this next example. Number 18. Number 18, they tell us angle 1 and angle 2 are equal. And we know that this angle here is 140. Well, this angle that's 140, and if you add angle 1 to that, that is a straight angle. So we can find angle 1 because what? Straight angles have a sum of 180 degrees. So angle 1 is 40, which makes angle 2 40 degrees as well. Just point there. Okay? So they want us to find angle 3. Well, angle 2 and angle 3 looks like it's going to make a straight line. So again, the sum is 180. So this angle is 140 degrees. 140 degrees. All right, let's look at the next problem. We use this figure here to determine the measure of the indicated angles. It tells us DA is perpendicular to CF, so that forms a 90-degree angle. AOB, they say, is 28 degrees. And they want us to find the angle EOC. Okay? They want us to find that angle. Well, the angle COB, because they are perpendicular lines, they form a 90-degree angle. So that's 62 degrees. But if this part is, if it says the angle, the line DA and CF are perpendicular, so that's a 90-degree angle as well. And let's see, what else do we know? Well, here we have, this is 90 degrees here. That's 90 degrees. This here is like a transversal. And this angle here of 28 degrees is going to be equal here, which is 28 degrees. This is 90 degrees. So the angles COE OE or OEC, it can be called either, will be 90 degrees plus our 28 degrees, which is 118 degrees. These opposite angles are equal. Let's look at another one. Number 24 says to find one pair of supplementary angles. Well, there are several, actually. Angles 2 and angles 5, they make a 90 degree, make a 180 degree angle. Angles 1 and angles 2, they make a 180 degree angle as well. And also 2 and 3 make a 180 degree angle. All right, let's look at this next figure. It says lines that appear to be parallel are parallel, and determine the indicated angles. So this is a situation where we have two parallel lines, we have transversals, and we need to think about what's equivalent. Here, this angle is 50 degrees, okay? And since this angle is 50 degrees, then this angle here is 50 degrees. Those are alternate exterior angles. Alternate exterior angles. As well as this angle 1 is 50 degrees. Those are called corresponding angles. Okay. And this angle here, 3, with this angle down here, they make a straight angle. So they have a sum of 180. So this angle is 130 degrees, which means angle 4 is 130 degrees because they are corresponding angles, which means angle 2 is 130 degrees because they are alternate exterior angles. So number 26, angle 2 is 130 degrees, and number 28, angle 3 is 50 degrees. Okay, so we had to look back and talk about alternate exterior angles, corresponding angles. We didn't really talk about alternate interior angles. It didn't come to play with these two examples, but it could have come to play elsewhere. All right, now let's look at the figure we have here. It tells us that BF is parallel to CE, and FC is perpendicular to AD. And it also tells us that the angle ABF is 148 degrees. Now, they want us to find the angle ECD. Well, because these lines are parallel, corresponding angles are going to be equal. This angle here, FBC, forms a straight angle with ABF. So the sum, there is 180 degrees, so this angle is 32 degrees. And because of these corresponding angles, this is also 32 degrees. So the angle ECD is 32 degrees. Now this angle here is also 148 degrees. It's a corresponding angle as well. And in number 32, we need to find the angle BFC. BFC. Well, knowing that this one is 90 degrees, and we know that there are 180 degrees in a triangle, we subtract the 90 degrees and we subtract this measure of 32 degrees, and it gives us 58 degrees. So this is 58 degrees.